Hey everyone, so in today's lesson we're going to talk and focus on data collection. So we introduced the Pygame library yesterday where we can create a task. But if we're going to create a research study where we have participants come in, sometimes we want to get a little bit of extra information from them before they start the task. So we can ask questionnaires or we could just get a little bit of a background history. And there are a couple of different ways of doing that. Today I'm going to show you introduce REDCap surveys. We're going to talk about that briefly, and then we're going to move into tkinter, which is what we're going to actually use to start our Pygame and actually interact with the Pygame environment in the beginning and end so that we can keep our participant numbers separate. After we go into that, we're going to go a little deeper into Pygame, as I mentioned in the last lesson, and we're going to talk about keyboard inputs, mouse inputs, and even a little bit on controller inputs so we can actually get information from the user that's playing, similar to the space that we used in the examples yesterday. Once we're done with that, I'm going to briefly go over saving your data. So we're going to learn how we've already read in text files and we've saved the text files, but now we're going to add to that and we're going to save Pandas Dictionary as an Excel sheet. So it's a little easier to read after you've saved it. And we're also going to have an additional backup method of keeping our data just in case our program crashes so that we can just copy and paste at the very end before the game closes in case there's something wrong with the computer and we don't lose all of our data. So to get started into REDCap, I'm going to take us over to this link that you see right here. And this is a link that is designed specifically for the Wake Forest University School of Medicine as a general overview of how REDCap works. I'm not going to go into the details of this, but I will leave this as a resource. Anybody can access it. It's not restricted through login, so anybody on the internet can access. And you can just go through start. So when you go in here, it has some nice tutorials and they have some little GIFs that pop up and show you exactly how you can navigate specific things within REDCap. The main goal of REDCap is a graphical interface for you to drag and drop to create fields. So if you want somebody to type their name or their age, you can just create a text field for them to type their name or their age or whatever else you wanted them to enter into your form. You can pull up really quick with REDCap. REDCap is also nice because it has an e-consent framework that is linked into the IRB system. So if you wanted to get consents for human participants that are playing, then you can do this digitally and you don't have to worry about having all the paper trail. Everything is emailed, you have a digital backup, and you can access it anywhere at any time. It just makes life a little bit easier. And this is something I think is really important when you're learning how to code, because you can have your task, you can have all these things automated for you, but a lot of times you're still limited by the paperwork or the logistics of getting somebody into the office. There are also some other digital methods where you can pay with Clean Card now instead of using actual cash. You don't have to have receipts. You don't have to go back and forth. So it just makes life easier. So this is just one introduction. And if you need more help on this, then I can help you later on here. Okay, so let's go ahead and move on. We're going to go back into Pygame, and we're going to talk a little bit about tkinter. So tkinter is very similar to the standard application or the standard program that you would have running on your computer, where you when you installed all of the programs that we did in this course in lesson 1 or in lesson 0, we had those little pop-ups that said, are you sure you want to install? And then you had to click the little check boxes, and then you had next over and over, and all of these windows would come up. That is essentially a tkinter window. It's just a standard screen that comes up that allows you to enter information. It has pre-made button boxes, pre-made text entry, and you have labels, and you have all of these different things that are already pre-established where you can just quickly call them via the tkinter library. It's very similar to the way that REDCap works, but REDCap is hosted online. and is a little bit more user-friendly and has a lot more templates where people have already created tasks. Tkinter gives you the freedom to do whatever you want, change your colors, change your structure, change your font, change anything you want. It is your program, your application that you're able to create. Okay, so to get started, I'm going to come over here like we always do. I'm going to click on my folder, create a file, and I'm going to say lesson 04.py. All right, we'll pull it out to the right so we can be working on it as we follow along. Let me zoom in just a little bit. Okay, so in order to start Tkinter, just like with any other library, we are going to need to import it. So we're going to do import Tkinter, Kinter, and we're going to import it as TK because Tkinter is a little longer than some of the other import packages that we use. Typically, Pygame, we just keep it as Pygame because if we did Py, it would be abbreviated for a lot of other things, and Pygame is kind of short. Tkinter is very easy to misspell. So anytime you're importing a package and you think you might misspell it, it's a good idea to just change that abbreviation to something that's very specific. So TK is probably not going to be used by other libraries you're importing. And because we are also using Pygame, we're going to go ahead and import Pygame so we don't forget later. Okay, so as you can see, Tkinter, it shows that it is, it's not giving me the little squiggly underneath, meaning that it is likely installed on my machine. But if you, just like in other lessons, if you do have that little squiggly and you hover and it says it's not found, or if you run it and it says it could not find Tkinter, then you just need to go down and do conda install Tkinter. If that doesn't work, you can search to find the troubleshooting. Sometimes you need conda forge or pip in order to install. Okay, so the way Tkinter works is similar to Pygame. We first have to initialize our Tkinter, and we initialize it a little bit differently. So in this case, we create an instance of the Tkinter menu, and we call it root. So we say root equals TK, because that's what we imported Tkinter at, dot capital T lowercase k. This is their way of saying we're going to start a Tkinter window. Okay, so the next thing we're going to do is we can go ahead and give it a title. So we'll say root.title, similar to in Pygame. And we're going to say start menu for my cool game. All right, and then that's going to be the title of that window, similar to the title of the window we used in Pygame. All right, now we can go ahead and add some stuff to that window. So I'm going to come down here. We're going to say tk dot capital L-A-B-E-L. This is for a label. So this is just putting text on the actual window itself. This is no input. This is just similar to a print statement, but we're printing it to the Tkinter window. And we're going to tell it we want it to put this label on the root instance. So that's what we created our Tkinter as. And we're going to do the text that we want it. We'll say text equals. And this tells that tkinter.label function that this is the text part that we want to give it. And we can say enter your name. Okay, and then once we're done putting all the text in that we want to type in that label, we're going to type .pack. Now, what .pack is doing is, imagine you're creating like some note cards and you're putting them like on a table, and that table is your window. You write down the stuff you want on the note card. So one of the note cards could be a label where you put information on. One of them could be an entry where it's like an empty line where they're supposed to write something on. You take all those note cards, you create them, and then you pack them on the table, or you line them up on the table in the order that you want them to display on that table. So the first thing that you pack onto that table is going to be the first thing that you see at the top left of that table. Now, we can change the formatting of our window so you can have it left to right, so everything is packed in like one single row, or you can, by default, typically it'll do everything in one single column. Sometimes you can do like a grid structure if you wanted to have like multiple things left and right, but we're not going to get anything fancy right now. We're just going to keep it simple. We're going to pack it into the window, and let's go ahead and type in an entry as well. So an entry is tk.entry. So this is similar to that get user input that we talked about in the 01 lesson. So we have print statements, similar to labels, and entries, which are similar to those get user inputs from the terminal, but this time we're going to get it from the window directly. And when we do that, we're going to tell it where are we getting the entry from, and it's going to be that root window. All right, so we also, just like we do when we get user input, we need to assign it to a variable. So we're going to say, let's say user name equals. Okay, and we'll just say ID username because this is the ID of that person. So it's always a good idea if you're creating a game and you have multiple people that are going to play it, you want some kind of identifier that is unique, that cannot be duplicated, so you can go back and make sure the data that was collected was assigned to that particular participant. Okay, so then once you're done creating that, then we're going to do ID username.pack. And that's just like we did here. We're just going to pack it into it. Unfortunately, we can't do it all on the same line because we do have to assign it to a name, like we do with that get user input, but it's simple, 2 lines. And then now we've packed in our label and we've packed in our entry for somebody to type in their name. Okay, now that we're done with that, we need to initialize some of our variables that we're going to use. When they actually type their name in, we're going to have that go into that specific name. So this is just the ID of that label, of that note card that's on our table, not the actual name that they typed in. So we're going to say, we'll just say username, just to be simple. Okay, username, we're going to initialize it as nothing. So right now, we don't have anybody's username when we start the game. And we're going to create a function called start game, just so we can keep it separate. Oh, let's see. Let me go ahead and close that terminal out there since I accidentally hit. Don't hit Shift Enter because then it tries to run your line and it can crash your terminal. Okay, so we're going to start game, and we can, it's not a very good idea to use globals, but if you're creating a variable that needs to be accessed outside of a function, sometimes you have to tell the program that that variable is not only confined within that function. And when we talked about functions last week, everything that's tabbed over inside of this DEF like format here, all of this stuff is only local to the stuff inside of that function. And unless you return it down at the bottom, you don't get anything out of that function. Sometimes it will still work if you're all in the same script, but it's not a good idea to assume that, because if you split it up into separate scripts when your code gets longer, you'll realize that you no longer have access to any of the variables that were defined in that function. There is a way to get around that, and the way you get around that is by telling the computer whatever name you want to just always be available whenever you're running the program, no matter what script you're in, whether you're in the function statement or out, is to call it a global. So we're going to do global, and you notice how it turns blue, just like the DEF for function, because the program knows that you're creating this variable as a function. And then we can tell it we want username to always be available. You don't want to go around creating a whole bunch of globals, because then you can sometimes forget you have a global, and then you can rename something, and the global is always going to take precedence because it is always the first thing that is checked. And you can sometimes mess up your whole code because you wrote global in one of your scripts that you don't even use anymore. You just happen to import it. So don't use a global unless it's something very important that you're going to reference a lot in your code. In this case, because it's the user ID and it's the participant ID, and we're going to probably use that quite a bit throughout the saving of the data and the task and all of this, this is an okay instance to use global variables. Okay, so we're going to create username as a global so we can access it outside of this function. And then we're going to use that username. And we're going to say the username is whatever they type into that tkinter entry field. So we're going to say ID username, because that's what we called it, dot get. So we're getting the value. When we start the game, we're going to get the value of whatever the user has typed into that field. So we're not going to check until after they hit the start button. Okay, so we're going to do that. And once they hit that start button, we're going to go ahead and close our window, because we're going to pop the window up. It's going to ask them to enter their name. They're going to type their name in, and then they're going to click a button at the bottom that says Start Game. When they click that Start Game button, we want it to get the name that they typed in. We want it to start Pygame, but we also want it to close the window, because we don't want that window on top of our Pygame the whole time. So we're going to type root.destroy, and this is just going to close out that instance of that root tk window, tkinter window that we created. And then now that we've closed the window that asked for their name, we are going to start our Pygame. So this is the same as what we did yesterday. We're going to do pygame.init, and then we go ahead and initialize that screen. Remember, this is the internal screen that the computer is updating, and then we display that to the actual screen. All right, so pygame.display.set mode, and then we're just going to give it again 800 by 600 pixels, just so that we can still see the rest of our computer. Full screen mode, sometimes if you get stuck in a while loop, it's a little more tricky to close out. Okay, now we have our function that starts the game. We have our tkinter menu up here. That's starting as soon as we run this program. But we also need to give them a button. So we have enter your name. We have a place for them to enter their name. We've packed both of those on there. But we're going to create a tk.button. We're going to tell it we want that button to draw on the root window. We're going to give it some text that we want it to say. So we'll just say start game. All right, that's what's going to be on that button for them to click. And we're going to give it a command. So this is where it's a little different than that label up here. And the command is going to be our whatever function name you had up here. So we called it start game. So we're just going to say whenever you click this button that says start game, it's going to call this function and run everything within this function. All right, and then it's going to create this as a global username. That way we can access it later without a specific return that comes back to this task. Okay, and then we also need to pack in order for it to show up on screen. And we're going to do root.main loop in order for the tkinter menu to actually run. So let's go ahead and save this, and we're going to hit run. And it's going to take just a second. It showed up in the background. Oh, there it is. Okay. It's really, really tiny. We can change the formatting and stuff of it. Let's see if I can move it. I think it's too tiny for me to be able to drag and move. There we go. Okay. So you can see the full title, start menu for my cool game. It has a label, enter your name. So I can enter my name here, and then I can hit start game. You can see Pygame started, and then it closed right out. And now we can put our actual Pygame in there, and you are ready to go. That is a tkinter menu. Okay, so now let's go a little deeper into Pygame. So we've introduced Pygame. We kind of know how it works. We know we have that while loop that's constantly flipping the screen. We can display things on screen, and we can even use different states to differentiate different parts of our game as we're playing them. Now we need to add to the interactability of our game. So in the last lesson, I gave you guys a little bit of code that was checking for the quit button to be pressed so that it closes out whenever we're not wanting the game open anymore. And we also had to switch between states. I gave you that check for events if spacebar is pressed. And that spacebar was actually checking what's called an event log on your computer. So your computer has, it's like a notification log that every time something happens that is an input to the computer, whether that be like you moving your mouse around on the screen, clicking the mouse, touch screen input. So if you have a touch screen and you're touching somewhere on the screen, or if you have a stylus and you're hovering above the screen, all of that is input along with keyboard input. Anything that could go into the computer is going to be sent to that event log, including clicking the X button. That sends a specific like quit command to the computer. That's constantly being updated. Pygame is running separate to that event log. And in order for Pygame to know what's coming into the computer, it needs to constantly check that event log. And that's where this for event in pygame.event.get. So pygame.event.get is checking the computer's event log, that input log from everything coming into the computer, and seeing if there's anything new that was added to that log, like a new notification. And if anything new has been added, we can now use a simple if statement to see, okay, well, was that thing that added, was it a quit statement? Or was it like somebody hit the X button? Or was it a key press? So we can have key down. You can also have key up. So if I were to come over here and I were to hit the enter key, when I press the enter button down, then it's sending a down signal. And then when I pick my finger up off of that key, then it sends an up signal. And there's also some timing and some other things that are inputs to the computer too, but we won't get into that in this course. Okay, so we first, we already have in our example here, we already have our Pygame running. We've already initialized it as screen, but we're not using it yet. So down here below that TK start menu button, once we start the game, it's going to continue running the rest of what we have. So we're going to say running equals true. All right, and we're going to start with just a state to be the task. So we're just going to go straight into our task because we kind of already have a menu set up. We don't really need an instructions menu in the task. It is still a good idea to have a simple instructions menu in your Pygame task after your start menu, just like hit the spacebar to begin, or look for the buttons or click the buttons on the screen, or whatever it is that your instructions are. You want to put that in your Pygame, but you can put the heavy hardcore like asking for their name and all this other information outside of Pygame, and it's much easier to use in tkinter than trying to code that with the spacing and everything in Pygame. Okay, so let's create a rectangle. So we're going to say our box equals Pygame dot capital RECT for rectangle. We're going to go ahead and give it, so we're going to say 200 for the left, 300 for the right, and then we're going to do a 100 by 100 here. Okay, so we're going to have a square, not really a rectangle. And remember, it's the top left of the box is where those 200, 300 location is. And we're going to go ahead and predefine a font. So we'll use the default font, again, like we did in the previous lesson. So we'll just do none, and then we'll do 36 point because that's a pretty good readable size. All right, so now we have our while loop. So while running, so we have running set to be true because we want the game to be running. Then we're going to say mouse position equals Pygame dot mouse dot get POS. This is a get position function that's built into Pygame, and this is just going to tell you the coordinates, the XY coordinates in pixels of where your mouse is currently. At the beginning of every single game flip, we want to know where is the mouse. So this is happening like very, very fast, multiple times per second, like millisecond precision. Okay, and then now we're going to get any kind of events that are going into the event log, like clicks or touches if you have a touch screen. So for event in pygame.event.get, this is the same as what we did yesterday. We don't want to forget our quit clause for event.type if it equals pygame.quit in all caps. So if somebody hits the X button, we want running to be false. If not, our program will be stuck in an infinite loop. Okay, but also if we have an event, we want to see, well, what if that event dot type is a key press? Make sure we type that right. Pygame dot key down. So there's key down or key up. If event dot key, so if that key that was pressed is the escape key, we can have a second backup quit. So now instead of just hitting the X button on your menu or on your Pygame screen that comes up, we can also just hit the escape button to exit at any time. So we're going to define that if it is the escape button by saying Pygame dot K, all caps, underscore escape. You can search all of these, the keys. So like key A would be K underscore A. There are some specific ones for like space. I think it's like just K underscore space, SPACE, DEL for delete. There's a lot of different ones. They kind of make sense. Some of them don't for if you wanted like K underscore A, capital K underscore A is lowercase, K underscore capital A would be your uppercase, and you can check for specific keys if you wanted to this way. Okay, so if somebody hits the escape button, we also want running to be false. Okay, but now we can check for that space. So this is the same thing that I had you guys type in yesterday. So if event.key equals pygame dot K underscore SPACE and state equals task. So instead of having to do an if statement and then putting your if event key within that if statement, we can use that compound logic right here. So we can have and, so we can say if they hit the space key and we're in that task, then we're going to do something. So we're going to say print, you pressed the space bar. Okay. And then, so this is checking for any kind of keyboard input, key down input. So it will register the exact moment that the key is pressed down. It does not register the moment the key is pressed up. If we wanted to register when the key is pressed up, we would need to do KEY up for key up. All right, so then now we're going to do one extra thing. We're going to register for mouse clicks. So this also typically works for touchscreen input depending on your device, but anytime that you touch the screen or you click your left button on the mouse, on your mouse or on your pad, then it will register in that event log as a mouse button down. So we're going to say if event.type, make sure you can spell event correctly, all right, equals pygame.mouse button down. I'm going to autofill that there. And then if the mouse button down, then we're going to say you pressed the mouse, or we can say you clicked the mouse. Okay. And then we can actually add a little bit more. So let's say at position, and then we're going to come here and say event.pos for event.position. If you notice in the guide that I gave you guys, I use this F format. I don't think we've talked about this in the course. So instead of doing this with a comma and then this and adding that space and having multiple statements within our prints, you can actually just use F to force it as a string, put parentheses around everything you want to type, and any parameter that you're going to put in there, so like your variable event position, which is a variable right now, put it in curly brackets, and it will take those curly brackets away and just replace that entire everything from, oh, I think I messed this up. Okay, let me fix this. Okay, I think I got it back. So we can use this F with the string written here, and it will replace this curly bracket event dot position curly bracket with just the value of that variable there. Okay, so we can also put like that box on screen. So remember we created a box and we have that box right here. So we haven't displayed the box yet on screen, but if the box was already on screen, we can check to see if they clicked the box. So if we just called it box.collidePoint, we call it collidePoint, that's just the function with Pygame. If box.collidePoint is event.position, So we put that as our parameter. And then we can hit enter. We can say print, yay, you clicked the box. Okay, so this is just a very simple game. We have a box on screen and they click the box. Now we have not actually displayed the box yet. Remember, we haven't blitted that box to the screen or drawn the box on the screen, but we are checking for all of our event stuff right here. And then this is where our mouse position, we can get that mouse position at any point that we want. Okay, so now let's scroll down a little bit more, and we're going to do one extra thing in our interactive. So if our box dot collide point mouse position, okay, so remember we created mouse position up here. So if the collide point is the current mouse position, so not the event of something in the event log. Oh, I need to back up just one more time here. Okay, so if we have this and it's the same, the box is in the exact same spot that our mouse is at the beginning of that flip of Pygame, then we're going to change the color of the box. So we're going to say box color equals, and then let's just say red. Okay, remember you can use RGB or you can actually type some of the most commonly named colors. So we're going to do else box color equals blue. Okay, so it's going to be blue most of the time, and then when we hover over it, it should change color, because if our mouse position is colliding with the positions of that box, then we're going to change the color. Otherwise, we keep the color blue. Now we can actually draw that rectangle. So pygame.draw.rectangle, we're going to draw on the screen. We're going to color it the box color, and we're going to give it the box object. So that box object is what we created all the way up here when we started. So we don't have to recreate that. And okay. And when we're doing our start game, we do need to call start game here. Okay. This right here will start our game before we initialize our game. So we're going to run into an issue in a minute, but we'll fix that. Okay, so now that we've done that, we're going to come down here and we're going to say, if somebody clicks, then let's go ahead and put like a collide point when it's on there. So we're going to tell them. So not just print it out in the terminal, because right now we're just printing this. If they click, then we also want them to see that they clicked it and give them some feedback in the game, not just for us to see on the back end. Because remember, not everybody's going to see that terminal there. So if box.collide point is mouse position and pygame.mouse.get pressed. So this is another way of checking for that key press that's in the event log, but it's not doing it constantly within each flip. It's just doing it that one time per flip of the whole screen. Okay, so then we're going to get 0, because 0 is going to give us our left click. 1 would give us if we right clicked on that object. Then we're going to create some text, and we're going to say that text is our font.render. You clicked the box. So again, this is not for us to see in the terminal like it was up here. This is for them to see on the screen. And we're going to give it true. We want it to be on screen. And then we're going to say, sure, let's just do yellow for our color for this one. And then don't forget to blit to the screen that text that you just created and tell it where you want it to show up on screen. When we're done with all this, we have to pygame.display.flip at the end of our while loop before we close it out. And then outside of our while loop, we're going to do pygame.quit. And we're going to go ahead and save that before we run it. Okay, so let's go ahead and fix this issue that we see here. Screen is not defined before we actually get started. So if you're ever running your code and you see this and you're like, I don't know what is causing this to mess up, if you hover over it in VS Code, it will tell you what is wrong with your code. So let's think about it. Screen is not defined. Well, we did define screen. We defined it up here inside this function. But if you think about it, this function has not been called, or it might not be called because it only gets called when somebody clicks that button. So it's not like we're just calling the start game function before we do this while loop. So it's possible that this game could sit here indefinitely and nobody ever hits the start game button, and then screen will never be defined. It will never start our game, which shouldn't really cause an issue because then we just don't start our game. But the code doesn't know that. The code just knows there's a variable that has not been defined. So there's a couple of different ways that we could fix this. One way, we could just say screen equals none, and then it would just run this, and then as soon as this finishes, it will not move on until it finishes this line. So then once it, because we have this other loop here, once that loop has been destroyed, then it will continue with the rest of the code. That's not a very good practice. We can try that. And the way we would just do this is just say screen equals none. And as you can see, it fixes our error here. So I'm going to get rid of that. Another way to do this is we are setting running equal to true. So right now we're going through this whole task here with running equal true. We can still set screen equal to none if we want to. But I'm going to take this and I'm going to move this up here to the top. And I'm going to say running is false. So we're not going to actually start this loop, even though the loop will not start yet. We're not going to start this loop until after we click the button and we start game. So we're going to create that screen right here. So screen is being redefined. And then we're going to say running equals true. So we start with the Pygame off. Even though it starts off natively, the computer wants to know explicitly that that Pygame is not on yet. Then once we click the button, we initialize the screen and then we turn the Pygame loop on. Hopefully that makes sense. Okay, so now you can see we don't have any errors. We're going to come here and we're going to hit run, and it's asking for the name. So I'm going to say this, and then when I click this start button, it's going to run this start game function. Let me just make this a little bigger so everybody can see. I don't know how high res the video is. Okay, and we're going to hit start game, and you can see it opened our game. So if you notice when we run this, it's not actually showing our game like we thought it should. So we're going to type this. It's just popping up and it's closing out. So we need to go back to our code and figure out what's going on. Why is it's running, it's starting the game, but this doesn't seem to be working. So the only thing that's working is this original Pygame initialize and the screen. But if we look at this, we notice that this screen and this running are kind of grayed out a little bit. So when we hover over it, it'll tell us that it's not accessed. Well, we created the running and we're using running. So why is it using this running and not that running? Well, if you remember, all of this stuff is inside of this function, and unless we return it, it cannot get out of the function. The only exception is if we create it to be a global. So that's what we're going to do here, and it's okay that we use a global because screen, running, and username are three things that we are going to access throughout the whole task. If it was a throwaway variable like something we're going to use to initialize a for loop, we would not want to set that to be a global. But if it's something that is very important, it is still good practice to be able to set that. So we're going to type screen, running, we're going to save. And as you can see now, these are no longer not accessed. So instead of this while running loop using this false, it's now going to access this after that start button has been pressed. So if we save and we run and we type our name, hit start game, we have our game. So if we're clicking, we can see we're printing to the terminal where we're clicking at on screen. If you have a touch screen, I'm touching it right now, you can see it's doing the same thing. And then if we hover over it, the color of the box will change like it should. And if we click it, it will show us on screen you clicked the box. Now I'm going to click the escape button just to verify that escape is working instead of just having to hit the X. And when I click that, it closes our game, so we know our game is working. And you have now created the foundations of any game or interactive task that you would want. You can do all inputs. You can use mouse. You can use the direction of the mouse to have something follow the mouse. We have an infinite number of possibilities now to create our task. Okay, so the last thing that we're going to go into is saving your data. So we can run the task and we collect all of this data. We have the user do stuff, but we don't want it to just be down here in our terminal the whole time. We want to save the data to a text file or to a file that we can access later. And it's very good practice to save this data in multiple different formats. So we talked a little bit already about saving as text files. We can read and write from text files, and we still want to do that, but there's a couple of different ways that we can do this as well. So in order to save the data in a text file, the first thing we need to do is we need to be storing the data somewhere throughout the task and not just printing it to our terminal like we are currently. So we can do this a couple different ways. The simplest way is to just create a list. So like up here when we're initializing all our variables, I could just say data equals open close. And as I'm going through here, as let's say when the mouse is pressed, I could say data.append, and then I can say click. So it'll just append that they clicked the button. I could also come here and I could say they clicked the space bar. So I can say space bar was pressed. So all of these different things that we have, we could also do hover. So if it's hovering over the box collide point, then it would allow us to hover it when we're changing our color here. So we could say append, hovered, whatever you wanted to do as we're playing the task here. Now I'm going to comment these out because I don't want a large data set every time we run through that hover. But well, let's keep these two. We're just going to get rid of that hover because the hover could be every single time it refreshes. Okay, so as we're doing this, when we're in between trials, it's a good idea to do all your saving in between trials and not as you're going through the task. We'll save to a data frame, such as a simple list, or we could use a Python or a Pandas dictionary, or a Pandas data frame, or we can use a Python dictionary. Whatever you want to use as your main data storage. Pandas is probably the easiest for using like an Excel save at the very end. So I would recommend trying to experiment using that data frame. But as you're going through, you'll save it to this data structure, and you don't want to save it to an actual text file until you're in between trials, because saving to and from the memory on your computer is a lot slower than saving to a simple data frame that you have. So the way that we can do this is put all of this in here. We're saving it as we go. And at the very end, what I'm going to do is I'm going to save this, this data. So I could save it as a text file with open and then your name of your text file. I'm going to use the letter A instead of W and R. So if you remember before, W was write, R was read, A is append. So a write will erase your entire content. So erase all and rewrite. That's what the R, or the, let's put some comment names right here so it doesn't get mad at us. Okay, so a W write will erase everything and rewrite it with the data you tell it to. A read cannot write data, so it can only read, so it's like read only. Right, and then append, what it'll do is it'll keep existing data, and then it just adds to the end. So append is like add to the end. Just like when we're adding to the end of a list. It's the same thing, but it's adding to the end of your text file. So all of these are the different ways that we can use our text file. For saving data, you're just going to want to always use that append. unless it's a completely new file, then you can write it and you know that it's a new file. But if you're saving it after every trial, I suggest using the append option. Okay, so as we're adding our data throughout the trial and we get to the very end, if we had a pandas data frame, we could just do data frame to Excel, give it that Excel name, and then indexing is false. It will automatically, when we create a data frame, we tell it the column names, the titles of the columns. So it will automatically put those columns at the top. So we can just use the simple command. It'll save it to an Excel sheet so we can go back, and maybe you are more familiar with using Excel for plotting, but we're going to get into fancier plotting and you won't need to use Excel anymore, hopefully in the next lesson. Okay, so now the last thing that I'm going to show you as an additional fail safe that I always suggest doing. So we want to print to terminal, we want to save to a data frame or a list, and then we want to save to a text file as we're going along. Maybe save another text file at the very end just to make sure that it's saved. You can't have too many fail safes. And then we want to display the results. So when you're finished with the task, we might not have access to the terminal if the game crashed, but we might still be able to see the game or the elements of the game, like the TK window that we started with to begin with. So the way that we can show all of this data then, so up here where I'm creating data, I'm just going to do like 1, 2, 3, 4. So I'm just going to pretend like this is the data throughout. We're going to append some other stuff as we go through. I'm going to create another instance of our tkinter window. So I'm going to say root equals tk dot tk, and then we can change that title to be game over. Okay, and then after we're done with that, we're going to insert something. So we're going to create a text. We're going to say the text is tk dot text. We want to give it that window, which is our root, and we can give it a height and then a width, just so it resizes it a little bit so we can see the full window. Okay, and then we're going to text.insert tk.end. Okay, and then this is where we're doing that different string where we can say here is the full data. Okay, and then put it in curly brackets. We have data here. It's going to replace that data because we did it with this little f literal string. It'll replace this with the data that is in our data frame here and anything that we have added to it throughout the task. All right, and then we're going to do text.pack to make sure it shows up on screen. We can add a button if we want to that will copy and paste that data for us so we don't have to select and paste. That's optional. You would just use this command here. I'm not going to type that whole thing out. You would just type that, and then it's like those little buttons that you see on a website where you click it and it just copies everything in the file or in that text string. Okay, so we're going to save, and then now we can run. All right, so I'm going to just type something here. Okay, so you can see game is working. If I click, right now it's just printing in the terminal. And then I can click here, click the box, and I'm going to hit escape. And it would help if I typed correctly. So let's make sure we spell insert correctly. And we're going to try one more time. Then escape. And you can see our entire data has now been saved. We saved it to a simple list, and we displayed it in this tkinter window, which we could then Control C for copy and paste, or we could put this button there to copy it, or we can send it to anywhere else that we want, save it to a text file, and then we have access to that data forever. Okay, and that is it for today's lesson. Hope you learned something.